Hi, a bit of a show and tell for this episode. This is a little circuit board, a printed circuit board, which was from a time back in the 1990s. I used to get involved in designing bits and pieces for computers, and I kept this one because this is quite an interesting project. This is part of a networks business product, and the connectors at either end were called HISI connectors, which is a high-speed serial interface for networking. And interesting things on this board were all the integrated circuits along here used ECL logic, which is what the Cray computer used. It's very fast but high current logic. So this project was something I spent a bit of time building. It's a multi-layer board, and when you're designing circuit boards for these companies, they have things like this where all the different parameters are required and rules and regulations for designing circuit boards had to be kind of worked through as well. But unfortunately this one only became a prototype. I did build it up with the components, but the software wasn't ready, so this project collapsed. I have done other things. It's just a DIMM, basically a little computer memory at some point. But moved on to a splinter company actually and did another project which is quite interesting. This one was actually just a network card, but it was a Gigabit Ethernet card. At the time it was one of the first for that. This IC is an Intel device, and they had just actually were releasing that when I was designing the board. So this was one of the first prototypes, and in fact, being a prototype, there was a mistake on it. This, if you look closely here, the edge connector had to have reworked because I'd got the mirror image on the edge connector and the wires were all in the wrong place, the tracks were in the wrong place. But again, this is a multi-layer board, and a little bit about the project itself, because of the complete design here. Well, this is the schematic for it, complete with notes and also even a bit of scribbling out logic here. So this was when it was being developed, and then of course onto the actual circuit board layout. And these are, for say, are multi-layers. So there's actually about 8 layers I think on this board, and we've got one here that's unpopulated, so this is the board with nothing on it. And you'll see this is the layout on what we call the solder mask, I think, for the top side. And then underneath layers, well, this would be the copper layer on the top side or component side. This technique here was called thieving. It was particular to the company at the time, or actually the company, the previous one, Digital. This was the second layer, ground plane layer, and of course because you've got an external plug-in at the network, there was different planes for ground. Next layer underneath, there's a power plane at 2.5 volts. So this IC used a number of different voltages which had to be generated on the board from the supply taken from the PCI bus. There's also a 1.5 volt plane, more commonly 3.3 volt plane, that's power plane, another 1.8 volt plane. So quite a number of voltages there derived on it, and then the solder side at the back of the board, and just a layout or solder mask on the bottom of the board. So all these diagrams are for the project itself. Back to the boards, there were 2 variations. The latter one, this was the magnetics for the RJ45 connector. That was then removed, and the RJ45 incorporated these in the next revision up. But to say the ICs for Intel, which is this ball grid array device, was just being developed, and at the time there was very little information on it. Intel were very good at not giving you all the information you needed when you were designing things, but you really had struggled to to get these documents at the time. And even with the information I got from Intel eventually, they didn't say about the software that needed to go with it, so it needed downloaded software as well. So it took us a wee while to get it working, but obviously it's just part of the process for developing a new product. Anyway, hope you found that quite interesting. Thanks for watching.